CSIR JRF net physics class, nuclear physics class number 4. Some questions based on nuclear models, liquid drop model, etc. Some questions based on nuclear models. All are previous CSIR JRF net questions. So first question is from liquid drop model of nucleus. The question is, of the nucleus of mass number A is equal to 125, the binding energy calculated from the liquid drop model, given that the coefficients for the Coulomb and asymmetry energy are S equal to 0.7 MeV and A asymmetry. A asymmetry is 22.5 million electron volt MeV and respectively is maximum 4. അപ്പോൾ ഏതിനാണ് ബൈൻഡിങ് എനർജി മാക്സിമം എന്നാണ് ചോദ്യം. നമുക്കിവിടെ കോൺസ്റ്റൻസ് വെയ്സാക്കേഴ്സ് ഫോർമുലയിൽ വരുന്ന കോൺസ്റ്റൻസ് എ സിയും അതുപോലെ തന്നെ എ അസിമെട്രി തന്നിട്ടുണ്ട്. അപ്പോൾ ഇത് ആൻസർ ഈസ് 54 സെനൻ 123 then 23 I 124 52 T 125 and 41 SB 125. Suffix or prefix you note carefully. The answer is C, that is tellurium. T 52 is the answer. Answer C, atomic number 52. And here the atomic number in this case can be calculated for binding energy calculated using the equation given below. For maximum value of binding energy, the equation is Z0 is equal to for AC plus A0 plus A0 A raised to 1 by 3. AC and asymmetry, the equations are given. There you study the equation that we simplify. You see the first term, we have to multiply the numerator and denominator by A, then we get the second term in the RHS in the first line. You substitute for Z0 is equal to 4 into 22.5 into 125 plus 0.75 cubed into 5 cubed raised to 2 by 3. Then comes 8 into 22.5 plus 2 into 0.7 into 5 cubed raised to 2 by 3. Here you know it is proportional to radius cube. A cube. So Z0 is 11250 plus 17.5 by 180 plus 55. The answer is 11267.5 by 215. That is equal to 52. So ZO, the element, is 52. Then comes a classical nuclear model question, that is Bohr model or a Sommerfeld model, that model question. In a classical model, a scalar spin zero meson consists of a quark and an anti-quark bound by potential V is equal to R plus B by R square. That is the classical nuclear potential, where A is equal to 200 MeV, Fermi femtometer is to -1, and B is equal to 100 MeV femtometer. If the masses of the quark and anti-quark are negligible, the mass of meson can be estimated as approximately 141 MeV per C square, 283 MeV per C square, 353 MeV per C square, 453 MeV by C square. All are by C square. And remember, the calculation is a little difficult, so you better remember the mass of meson. Mass of meson is about 283 or 280 something, in that order. So it is better to by heart the answer 283 MeV by C square. That mass will be converted into energy. We can write in this expression. Actually, it is 283 electron mass. And when this electron mass we convert it to the form of energy, we get MeV by C square. So answer is B. That is the order of the measured mass in this case. Now comes a shell model question. The outermost shell of an atom of an element is 3D cubed. The spectral symbol for the ground state is, the atomic state is given, and we have to write the spectral symbol. Spectral notation we have to write, that is 4 of 3 by 2, 4 of 9 by 2, 4D 1 by 2, and 4D 1 by 2. And this is the last electron. If you take the atom, the outermost electron is represented by 3D cubed. From that we can find the nuclear rotation or the spectral notation. Spectral notation of nucleus. That you will write. From D cube we get ML. ML is magnetic orbital quantum number. That is equal to the values are -2, -1, 0, +1, +2. D is SPDF state, suborbital state. SPDF means L is equal to 2. When L is equal to 2, ML is -2, -1, 0, 1 to 5 values. That is, there is 10 written. It is not a 10. It is -2, -1, then 0. Or space it would +1, +2. The values, the different values. We can write using commas. -2, comma, -1, comma, 0, comma, +1, comma, +2. These are the ML values for D state. D means SPDF. For S, L is 0. For P, L is 1. For D, L is 2. 12 plus 1 values, 5 values. And the 5 values are -2, -1, 0, +1, +2. They are written. Then highest angular momentum, that is sigma ml. Highest angular momentum, sigma ml. Sigma ml, that is L value, total L value. SPD. So total L value is 3. No need of adding them. You can write as 3. For L, SPDF. In the notation it is D. So L value is SPD. L value is 2. And the maximum value comes as 3. Then for and the lowest J we can write as modulus. J is actually in vector notation, it is L plus S. J vector is L vector plus S vector, and here we take the minus value. L value, when we take L value 3, S value we have to take 3 by 2, so it is 3 minus 3 by 2, that is 3 by 2. The spectral term 12 RXL or RXJ. In that manner we write when RXJ, and for L is equal to 3, the symbol X is equal to F, SPDF, that is F stands for L is equal to 3, and J is 3 by 2, and R, that is 2 plus 1, which is 4. 2 into 3 by 2 plus 1, 4. 4 of 3 by 2 is the answer. Option is A. According to the shell model, the spin and parity of two nuclei, SP and SR, are respectively, the parity we have to find. That is 5 by 2 plus 5 by 2 plus 5 by 2 plus 7 by 2 plus 7 by 2 plus 5 by 2 plus 7 by 2 plus 7 by 2. plus. Answer D, that is 7 by 2 and 7 by 2. And here for SB 51, SB 123, A is 51 and N is A minus Z. That is 74. Z is 51. And here the parity we calculate by this equation. A1 to S1 to square, P1 to raised to 4, P1 to raised to 2, D5 3 by 2 raised to 4, etc. We calculate, then we get the last value. Last is, that is SPDG. SPDF GH. So G is the last term. Their base is 7 by 2. That is J value. So J is 7 by 2. And for G, L is equal to 4. Therefore, spin and parity 7 by 2. 7 by 2 and 7 by 2. For the next element also, in this manner, we calculate the parity and we get the parity 7 by 2. So the total, the parity of the two elements is 7 by 2, 7 by 2 plus. Next question, according to the shell model, the total angular momentum in units of H and the parity of the ground state of 3Li7 nucleus is 3 by 2 with the parity negative, 3 by 2 with the positive parity, 1 by 2 with the parity positive parity, 7 by 2 with the negative parity. The answer is A. The answer is A. That is 3 by 2 with the negative parity. Here Z is equal to 3, N is equal to 4, A minus Z. For odd parity, for odd Z is equal to 3, odd parity. And it is S 1 by 2, 2, P 3 by 2, 1, we get J is 3 by 2, L is 1, and parity minus 1 raised to L, that is minus 1 raised to 1, that is minus 1. Minus 1. So J is 3 by 2. J is 3 by 2 and it is odd parity. J is 3 by 2 we have obtained. Answer is A. J is 3 by 2. That is written first with the odd parity, negative parity. Because parity is minus 1. Minus 1 is called odd parity. Next question, let us approximate the nuclear potential in the shell model by a three-dimensional isotropic harmonic oscillator, since the lowest two energy levels have angular moment L is equal to 0 and L is 1, angular momentum quantum number L is equal to 1 respectively. Which of the following two nuclei have magic numbers of protons and neutrons? According to shell model, you have studied magic numbers 2, 8, etc. Magic numbers you have studied. And here the question is, which of the following two nuclei have magic numbers of protons and neutrons? Magic numbers പഠിക്കണം. Magic numbers ഇവിടെ ഏതിനാണ് വരുന്നത്? അവിടെ helium and oxygen, their atomic weight and mass number are given. Then D and neutron and beryllium, helium and beryllium, helium and carbon. Answer A. For helium, Z is 2, N is 2, A minus Z, 2. For oxygen, Z is 8, N is 8. So magic number is, you look here, the first number is 2, the second number is 8. And the magic number, 2, 8, 20, 28, 50, 82, etc. You have studied. That is the whole number of neutrons and protons in the nucleus which have maximum stability. Those nuclei having nucleons equal to magic numbers have maximum stability according to shell model. And these are the magic numbers. Here helium 4 and oxygen 8 have magic numbers. So the answer is A. Answer is A, helium and oxygen. All others have any of the magic numbers wrong. That is the answer. With this, our fourth class is over. We continue our class. Thank you.